Good afternoon, everybody. I hope you all are doing fantastic. It is the week of the AP exam. I know this is the week we've all been waiting for, or dreading, or preparing for, or whatever your case is since August. Okay, it was supposed to be last Friday, May 15th, and then with the changes with the pandemic, it has been pushed back to May 22nd, which is this Friday. So we have been preparing for this day for a long time. Over the past 2 months, we've spent a lot of time looking at what the new test is going to look like, and we'll touch on that a little bit tonight as well. But I hope you're all well. I hope everybody's healthy, and we will hop right in. So I've noticed that a lot of you have already put stuff in the Q&A. I've been kind of checking on that over the past hour or so. Some of it we will get to through what I had planned, and some of it I didn't really have planned in the slides, but we will come back to that at the end and go over that. So hang on to that. I know there's some questions about binomials and things like that, and we will touch back over that. And some of the other questions I'll try to incorporate with what I already have planned. Okay, so I will do my best to answer your questions that were already in the Ask a Question box. So just know that that's coming towards the end. I had a little bit of time for Q&A at the end, but y'all are a little bit ahead of me and already had questions, which is fine. Okay, so let's go ahead and hop on in. Nope, meant to delete those slides. So this is our weekly stream calendar. Things are obviously winding up because AP exams are halfway finished, and at the end of this week, they'll be completely finished. The big live stream for statistics that I want to push is the 5-hour Cram session finale, which is on Thursday, May 21st, which is my birthday. I'll be peeking in a little bit to kind of see what's going on with our other great statistics streamers that we have at Fiveable. So I would definitely hop in on that. A lot of great feedback so far from other subjects. Thank you for the happy birthday wishes there. Kind of a busy week to be a birthday week. But the other Cram session finales, people have came back after their test and said that that was the best 5 hours I've spent, and it prepared me exactly for what I was going to have on the test. So I expect AP statistics to be the same way. I think it would be 5 hours well spent. We are definitely thinking that it's going to be a great option for you guys to take advantage of Thursday before your test. Okay, so check out the Fiveable website, fiveable.me, and make sure that you are good to go. Will there be practice during the Cram or just content? I think it is going to be a little bit of both. I think it's actually going to be more practice. And I do not know why the free replays will not play. Some of the replays may not have been downloaded and uploaded. So we have to download them from Crowdcast and then re-upload them to the Fiveable website. And sometimes that takes a little while. I know a few weeks ago, it took me 2 days to get mine to download. So I would check back tomorrow if it's the stream that was from this afternoon. I think that would be good. Okay, so Josie, you did the 5-hour Cram for bio and APUSH, and it really was helpful. That's awesome. APUSH, I know I saw people in the Slack saying APUSH, the 5-hour Cram was great. And there was another one that I saw that they were like, it literally was perfect. I don't remember which one it was. So yeah, take advantage of that, guys. If you don't already have a Cram pass, I think there's probably an option where you could hop in Thursday for that. I think it would be really helpful for you. I know it's hard because it's already feels like summertime, but take advantage of that. So a great way to find out about those, go to our social media, and you can probably find the links for those. Okay, it's only $5 for the 5-hour finale Cram pass. So so I think once you go to the fiveable.me website, and it's kind of pops up and you can find it there. Okay. All right. Well, went too far. So what we're going to look at today, we're first of all going to focus on the different interpretations that you that you might see and things that you want to look at. So last week I went over the formula sheet and we added annotations to the formula sheet as part of our cheat sheet packet that we would use on our test on Friday. So now what we're going to do is we're going to look back at the important definitions and the important interpretations that you're probably going to be asked to do on the AP Statistics exam. And that way you'll have definitions and things to look for to prepare for that. We'll do a quick free response question. I really don't want to spend too much time on that, especially with the Q&A, because there has been so many questions already. So we will look at that. The link to the 5-hour cram pass. If you go to the Fiveable website, the homepage, and then hop over to subjects and then AP Statistics, it should be one of the upcoming events on there, and you can register for it and probably pay for the $5 there. Okay, so anyways, that is our kind of our agenda for the night, and let's go ahead and hop on in. So unit 1, the first unit that we are going to look at, pretty much guaranteed to be on there. Definitely make sure that you know how to cuss the data and make sure that you include context. If you're not familiar with that acronym of cussing the data, it's center, unusual features, spread, and shape. So that's kind of the 4 things you need. Center, unusual features, spread, and shape. So those are the 4 things you need. And as with AP Stats, you have to have context with all of your answers. Okay, so make sure that you do that. Your center, you know, whatever the units are, say your median is about, whatever. Okay, we got socks too. I've seen socks as well. Spread, outlier, center, and shape, that works as well. I don't know FUDs. That's a new one on me. Yes, socks with an extra C for context. I've seen that one as well too. Whatever you use, cuss, socks, FUDs, whatever acronym you use, make sure you know what it is that you need for your for that describe or compare the distribution. And always, always, always make sure you include context. Okay. I got you. Yeah. Form, unusual features. That makes sense. Okay. Also, so standard deviation, that is a definition or an interpretation that could possibly show up on the AP Stats exam. Remember that the standard deviation is the average amount away from the mean. And of course, in context, you'll see that probably 400 times in this presentation. So remember that standard deviation does not have a direction. It is just a magnitude. So it's like a length. There's no the standard deviation is never going to be negative or positive. You know, it always is, I guess, positive because it is a magnitude. It is that distance away from the mean. And it's the average distance away from the mean. So if all the test scores have a mean of 80 with a standard deviation of 5, then on average, test scores were 5 points away from the average of 80. That would be the interpretation there. Okay, so I have my context. Standard deviation is how far are you away from the middle, essentially. All right, now a z-score. A z-score is a standardized version, kind of like the standard deviation, but a z-score is going to measure how many standard deviations you are away from the mean. And by that, you need to declare direction. So whatever the direction is, you have to say, if it's a positive z-score, you are so many standard deviations above the mean or so many standard deviations away from, if it's negative, you're below the mean. Okay. So that is what z-score is. It's how many, not how many points, it's how many standard deviations that particular data point is away from the mean, either positive direction or negative direction. Okay. Be sure to include direction. If it's positive, be sure to include which direction it's going. Positive would be above the mean, negative would be below the mean. And of course, be sure to include context. So I think that's pretty much it for Unit 1. So those are kind of the big definitions that you would need for doing different interpretations there. So if you're doing standard deviation, you probably have a data set that is symmetric, and you want mean and standard deviation will go together. Those two always go together. So if you're describing a distribution with the mean, you should use standard deviation, and the shape should be symmetric. If the shape is skewed in one way, then you probably want to use median and IQR. And I see y'all kind of having a conversation over there in the chat on that. I can't really keep up and go over my slides because y'all are posting so much, which is fine. I like the conversation. So yeah. All right. So Unit 2, bivariate data, doing different things with regression. I do think the Cram is actually going to be very helpful. I've seen that question a few times. $5 probably not wasted at all. Okay. I would definitely do it. If you're willing to dedicate the 5 hours, I would spend the $5. Okay. So I would definitely do that. Yep. Katie is agreeing. Josie agreed earlier with the 2 classes she had taken, and somebody else took bio, I believe. So yeah, definitely. All right. So this is a computer output that you would have for linear regression. And in the past, we've had to use different things to answer questions. But this year, with Unit 9 being cut out, there are things that you don't really have to worry about if you have a computer output. So the SE coefficient, you don't need the standard error coefficients. You don't need the t-scores, and you don't need the p-values. Okay. You're not going to do inference with slopes for regression models. You never use the R-squared adjusted. It's very annoying that they actually even put that on there in the first place, but it's always on the output, and you never use it. Okay. So in your computer output, one of your variables is going to say constant. That is always going to be the Y-intercept. So that might be something worth taking note of. Regression, constant, Y-intercept. And that means that the other one is your slope. Okay. So the slope here would be 0.24. The Y-intercept would be 0.137. The S is the standard deviation. Okay. So it's kind of like the average residual. It's how far away you would be from the regression line on average. Okay. So that is what S stands for. It's the standard deviation of the regression model. Yes. So it's the standard deviation of all the residuals. It's how far, on average, are the residuals away from our line. Remember, we have a line, and we have points all around the line because the line is our prediction. And then the points, if we take the average distance from the points to the line, that's going to be your S value. And then R squared, we'll talk about that more in a minute. That is the kind of tells you how good your model is. In this case, it's pretty good because 0.873 is pretty high. Yes, the X value, the X axis. Well, it doesn't necessarily have to be because the R value, if you swap the X and Y, it's still going to be the same. You'll still get a linear correlation. So since we only do linear regressions, the variable isn't as important. All right, so the slope, that would be in this case 0.24. I use this chart again. This was from 2011 AP exam, number 5. That's the one I used to kind of start my question we'll do at the end. So the slope is the predicted amount of Y that either increases or decreases with an increase of 1 in X. Okay, so that's how much we predict Y to increase or decrease if it's negative with an increase of 1. Think slope is rise over run. So if your slope is 0.24, you can think of that as 0.24 over 1. It has a rise of 0.24 divided by 1, which is our X. So rise is your change in Y. Your X is your change in X. Yes, I know I have a Southern accent. Y, yeah. Good old Alabama boy right here. So sometimes my Southern accent doesn't come out, but it definitely does at times For sure. All right. Key points when you're interpreting slope, be sure to include predicted. Okay. Your regression line is predicted. The slope is a prediction. The Y-intercept is a prediction. Okay. Be sure to include context. As always, what is Y? What is X? All right. The Y-intercept. It is the predicted Y value when X is 0. So whenever my X is 0, the predicted Y is 0.137. And that would be, again, same thing. Be sure to include that it's the predicted Y value, and be sure to include context. We can look at a little bit of probability in just a second, but there are a lot of older videos that have some more specifics on probability that you can find on the Fiveable website. So go back and watch those replays sometime this week. All right, up. This is the R value, I know, or the R squared value. So the R squared is the amount of variation in Y that can be explained by its linear relationship with X. Okay, so 87.3% of the variation in Y can be explained by its linear relationship with X. Yes, you do not need to know permutations and combinations. I would even pretty much say that the binomial formula, you won't have to calculate it this year. In other years, yes, you would have to calculate it. But this year, I don't think you're going to be asked to calculate a binomial probability, which we'll look at later in the Q&A section, because that did come up quite a bit. All right. So standard deviation, that is the average amount. That's the S value. That's the average amount that our data points are away from our regression line. Always have context. And then if you needed to find R, you take the square root of R squared, and then you take the sine of the slope. So this is always going to be positive. So that means whenever you take the square root, it's always going to be positive. I'll go back to the R squared definition real quick. Oh, I went too far. No, I still went too far. Slide 9. Went the wrong way there. All right, so there is the R squared definition. Okay, so it's the amount of variation in Y, which is the response variable, that can be explained by its linear relationship with X. So it's important to include that linear relationship connection there as well. Okay. All right. Slide 10. So standard deviation, we kind of touched on that. It's the average of distance away from the regression line. So in other words, it's the average residuals. Be sure to include context on all of these. To find the R, we're going to take the square root of our R squared, and then we take the sine of our slope. So our slope is positive, our R value is going to be positive. Yes, R is the coefficient of correlation. R squared is the coefficient of determination. A little bit different. So R is the correlation coefficient. That tells you how well it's correlated. So if you needed to interpret R, you need to be sure to include the strength, the direction, and linear. We always do linear here, but you just need to include that. So here's kind of the template that you would want to follow. So there is a positive or negative. That is based off of if the R value is positive or negative. Yes, the slides will be available via the replay. So when the replay is up, the slides, you can click a link and get the slides. Okay. So there is a positive or negative. That is the whatever the sine of the slope is, or the sine of the R squared, of the R value is, not the R squared. Strong would be 0.8 or higher. Moderate would be 0.6 to 0.8, and then weak would be like 0 to 0.6. And then it's always linear correlation. We don't do any other type of regression in AP Stats between whatever your X is and your Y. Okay, so that's kind of that interpretation. I could see them giving you an R value as one part. Maybe that's the only thing they give you with regression. I don't really know how regression is going to work into things with this year's exam. So that's a possibility there. Okay, so Unit 3. So the interpretation of R is you basically are just looking at how strongly it's correlated to the data. So there's a strong, weak, or moderate based on how high the R value is, close to 1. And is it positive or negative? And then the fact that it's linear. So yeah, correlation tells the direction and the strength of the linear association. All right. I would make sure that you know how to collect random samples or randomized treatments. I would say transforming linear data to exponential or power model or by hand. I would say probably not. It's such a small portion of the test, but it does fall in Unit 2. We did a stream on that back in April, beginning of April. You could go back and touch on if you wanted to, but I kind of doubt it. It's just one of those little blips on the radar that I doubt is going to show up or be very prevalent. I wouldn't be too concerned about that at this point. So if you are collecting random samples, yes, so creating an experiment, make sure you know how to randomize treatments. That's a pretty popular question on past free responses. I could see them throwing that out as a part A or a part B of a question, and then having you do the inference type stuff. Yes. So I like the names in a hat method. There's a lot of ways. I think names in a hat is the easiest. So if you number each individual 1 to however many there are, put all the numbers in a hat, mix them up. You have to include mix them up. That gives you the randomization process that they're looking for. If you don't put mix them up, if you're doing the names in a hat, you won't need that. So then you're going to draw however many numbers you need for the first treatment. Those names matching those numbers will receive the first treatment. The remaining however many numbers are placed in the second treatment. Sometimes a placebo and a new drug, whatever it may be. Just make sure you're familiar with that process. How to describe a randomizing treatments process. And I would venture to say that avoiding specific vocabulary, if you're not really sure on which one was stratified and cluster, if it doesn't ask specifically like describe a cluster sample in this experiment, then I wouldn't use the words cluster sample. Okay. I've seen some sample questions that have came up where they've said, how could you redo this experiment so that this doesn't play a factor? And you split it up into 2 groups and take an equal amount from those 2 groups. You can explain that process without using the word stratified random sample, because a lot of people will get those confused and want to say cluster, and then you say cluster, and it's kind of like, oh, dang, like you said stratified and you meant clustered, or you said clustered and meant stratified, and then that bumps you down a point because you used the wrong word. Yes, Josie, that's a good point. I would include without replacement. So draw in numbers without replacement with the names matching those numbers, so yeah, include that. Yes, blinding is important because it's used a lot in the real statistics world. And it's one of those things that, like, if you explain it with what it really means and not have to go into the specifics of like the actual textbook definition, then you're probably going to be better off. So stratified samples. So a stratified sample is when, let's say that I have a bag of M&Ms. A stratified random sample would be to take all of the red M&Ms and put them in a pile, all the yellow, all the blue, all the brown, and all the orange, and then take 2 from each group. So my strata are the colors. So they're separated into groups they're all the same. And that way I know that my random sample that I take, when I take 2 from each pile, is going to have an equal number of each color. So that is stratified. A cluster would be if I just poured a little bit into each cup and then I picked one cup. So I had basically you're separating it out into 5 random groups, and then you pull one group as your random sample. Okay. But I could still, if I did that with M&Ms, I could still get a cup full of brown M&Ms. Okay, there's no stopping that. But if I separate it by color and do stratified, then I'm guaranteed to get an equal color distribution. Again, I kind of doubt those vocab words are going to show up in the prompt. They might allude to that, and you have to explain why that would be important or how to do that. But if you avoid using the specific vocabulary, then you'll be better off. It's usually always sample without replacement, because then you could have one person in both groups, and you can't have one person taking a medicine and one person taking the placebo. So always without replacement. Yeah, each strata could have a different number of individuals. There's nothing wrong with that. Yes, you check 10% because since you're sampling without replacement, it's not truly independent, right? I mean, there's one less person to draw out of, but I want to check that 10% condition to make sure that without replacement is not messing it up too much. Okay, the population is so much bigger than my sample that me drawing, one person out of 300 is not really much different than me drawing one person out of 299 because my population is so big. Okay, so that's kind of my that's kind of why we do that 10% check. Yeah, if you're trying to get a complete randomized sample, then stratified is generally better, but sometimes it's not always doable. Okay. All right. Unit 4, probability. So these are things that y'all have asked about, which on the probability, I would go back and watch some previous streams to get good review on those. So from a two-way table, if you are asked if two events A and B are independent from a two-way table, you are going to compare these two probabilities. Is the probability of event A equal to the probability of event A given B? If those two probabilities are equal, then A and B are independent. If they're not equal, they're not independent. That has showed up on pretty much every sample question I've looked at, or every sample exam from multiple sources. Also, it showed up a ton in past exams on probability. So I would make sure that you know how to interpret that if it asks you if two events are they are independent or not. Out dependent. Threw me for a loop there. Mutually exclusive. Two events that are mutually exclusive means that they have no overlap. That means they don't occur at the same time. Let's see. Can it also be that PA times PB equals PA given B? Yes, mutually exclusive and disjoint are the same thing. I don't think that is. So if two events are independent, then you can find the probability of A and B by doing A times B. But I don't think that they would be equal to P probability of A given B. To me, it's always easier. I'm trying to process that in my mind without writing stuff down. I really need to write that down. No, I don't think that's going to work. P of A times P of B. The connection with independence there is that if A and B are independent, you can find the probability of. Okay, so change given to and in your Cyrene in your first text there. Can it also be PA times PB equals PA and B? Change given to and you're good. Yes, perfect. Yep. What you just said in the example, probability of female times probability of pierced equals probability of female and pierced. If those two things were true, then yes, female and pierced would be independent events. So yes, the other one is also true because the P of A's would cancel out. Okay, P of A cancels out on both sides. You end up with the same definition as what I had. Okay, so yeah, mutually exclusive means there's no overlap. So if you see a 0 in one of your cells of a two-way table, that would mean that those two events would be mutually exclusive or disjoint. Okay, binomial. A lot of people asked about that in the chat. So I think what you're going to need to be able to do with binomial is to state when something is a binomial probability. So much of binomial hinges on calculating that with 25 minutes for a question and not everybody having equitable access to a calculator, I don't think that binomial is going to show up in terms of calculating. But they could give you an example and explain why it's binomial. Okay, that's my thoughts on that. So the 4-stage thing of why it would be binomial. So yeah, kind of like the conditions, exactly. So the conditions for a probability to be binomial. So you can break up the word binomial. So does it have a clear success and failure? Okay, is there a clear, flipping a coin is binomial. You have heads and you have not heads, which is tails. Okay. So is there a fixed number of trials? Am I flipping a coin for 25 times? If I'm flipping a coin for 25 times, that would be a binomial probability. I agree. The conditions do suck. It does get annoying sometimes. Are the trials independent of each other? My second coin flip is not affected by my first coin flip, so they're independent. And then are all of them equally likely of succeeding? Okay, all of them would be 50-50 of getting heads if I flip a coin 25 times. So yes. So I think you could have a question where it wants you to clarify why it is binomial. And that would be the 4 things you're looking for. Okay. So the difference in binomial, well, see, a proportion a binomial is an example of proportion because a proportion is just a probability. But a binomial is a particular way in which an event is set up. So I could have an event set up as a binomial variable. I could have it set up as a normal variable, which is follow a normal curve. I could have it set up as a geometric variable. So all of those things are different types of random variables that you calculate probabilities with. So they all have proportions. There's really not a difference. It's just if it's a problem that's written out in a way that's binomial, then it's binomial. So PDF is point density function. You would be calculating the probability of flipping a coin 25 times and getting exactly 6 heads. Okay, so just falling on 6. And then CDF is continuous density function. So that would be like at least 6. So that would be 6 all the way to 25 if we're flipping it 25 times. And geometric, kind of the same, sort of the same as binomial, but the only difference is there's not a fixed trials. So geometric, you're typically flipping a coin until you get a heads. What's the probability that it takes exactly 2 flips to get heads? So more in depth on the all trials part. So that like flipping a coin, the flip of getting a heads, the probability of getting a heads on the first flip is the exact same as getting a heads on the 25th flip. It's 50-50 every time. Okay. So the probability of getting a heads is 50%, 0.5 every single trial. All right. It's not like it changes as time goes on. Yes. So we do not use normal PDF, just normal CDF, and binomial is, yes. So the P and Q there. So binomial CDF is like at least 2. So 2 to, 500, however many trials there are, and PDF is exactly 2. So what's the probability I get exactly 2 heads? So yeah, geometric's very similar. I would just make note that it's like binomial. It just doesn't have a fixed number of trials. So I'm flipping my coin until I get a heads. Okay. Yes, P and Q, I think is fine. Or versus P and 1 minus P, I think it's fine. If you write P equals 0.23 and Q equals 0.77, you're good. They know what that means. I think I've seen rubrics before where they mention that as an alternate. Q is just another way of writing 1 minus P. If you're doing 1 minus P, which is the complement, just keep it doing that. Some teachers teach Q. Some textbooks have Q. Same difference. Okay. So yeah, if you have geometric, also make sure you explain the by, the I, and the all. So, and just state that it's not a fixed number of trials. All right. So Unit 5, sampling distributions. So remember, when you are calculating probabilities with sampling distributions, you need either large counts, okay, or the central limit theorem. That is your normal check for when you do inference. So make sure, whichever type of problem you're dealing with, if you're dealing with proportions, make sure that you do your normal check and you explain that the sampling distribution of our p-hats is approximately normal. Make sure you include the word approximately when you're explaining that normal check. Make sure you clarify if it is means or proportions. Our sample means, which is your x bars, our sample proportions, which is our p-hats. Okay, make sure you clarify which sampling distribution is approximately normal, and then also clarify which curve that's going to lead you to use. So if it's proportions, say that allows me to use the z-curve to calculate our p-value. If you're doing means, it allows me to use the t-curve. Okay, that's coming off the sample question off of College Board's website. That was the key that a lot of people were using, and it needed those three things: approximately normal, what distribution was approximately normal, and then what curve did that lead us to use. Okay. We also need independence, which that is the 10% condition. When you're doing inference, you also need the random check as well, so you can make inference to a population. CLT is central limit theorem. That's the n greater than or equal to 30. And then I got ahead of myself there. So yeah, so which so when they give you a normal check and say, why is this important? Then those are the three things that I think are really important. You need the sampling distribution of either your x bars, your p-hats, your x bar 1 minus x bar 2 if it's a two sample t-test, your p-hat 1 minus p-hat 2, whichever one is approximately normal, which allows me to use one of these two curves. Okay, if you have all three of those components, you're good to go. You can't just say normal. Like in the past, you could say normal and then write your check out. They want to know, like, well, what does that mean for it being normal? Okay. And then, of course, context, like the sampling distribution of our sample means of, hair length or whatever it is we're doing. All right. So then inference, and that's sampling distribution leads into inference. And then we'll see what we got. So confidence interval, we are blank % confident. This is kind of your template to go by if you were asked to interpret a confidence interval. Yes, I can go back real quick. I think that was it. Context. Yep. Give me a second to catch my breath too. Trying to cover a lot of content. I know a lot of this is going to be touched on again on Thursday in the Cram finale. So I can't promote that enough. I know 5 hours is a lot of time at the end of May to devote to one class. But 5 hours on Thursday is a lot better than several hours taking a college course. So you would, and it's a lot cheaper too. $5 is a whole lot more than college credit, especially if you're right on that border of a 2 and a 3. I think Thursday could push you into that 3, which most colleges accept. Yes, so these would be why you check for normality. Exactly. All right, so inference. So confidence interval. This is the template. Whatever your confidence level is, you are that much confident that the true mean or proportion or difference of means and proportions, whichever one, of whatever your context is between your 2 endpoints. Okay. I don't think you're going to be asked to calculate one. You might be asked to clarify what the point estimate is, which is the middle of your interval, and then your margin of error, which is what you add and subtract to get your interval. But I don't think you're going to be asked to calculate one. You just need to know what it means. Okay. And you can check a particular statistical claim by taking the null hypothesis amount and seeing if it's inside of the confidence interval. If it's not inside the confidence interval, then you got some reason to reject that claim. Okay. Whatever the complement of the 95% is. No, the point estimate is the number in the middle of your confidence interval. That's your X bar, your P hat, whatever it is that you were given from your sample. And then the margin of error is what you add and what you subtract to get your 2 endpoints for your confidence interval. Okay, we went over that a little bit more last week. So go back and watch last week's replay. To find the margin of error, you would take the top number and subtract the point estimate. Okay, or you could take the top number and subtract the bottom and then divide by 2. That would do it too. Find the total range and then split it in half. All right, so the confidence level. So if it asks you, what does it mean to be 95% confident? That means that if you repeat that process over and over again of constructing that interval, whatever percentage of them will include the true mean, proportion, difference of means, proportions of whatever your context is. So if I do 100 confidence intervals, 95 of them will contain my true mean or proportion that I'm trying to estimate. Remember, inference is all about estimating the truth. We're taking a sample and we're trying to estimate what the real deal is, the big deal. Okay. So if I have a confidence interval that's 95%, then that means if I did this process 95 times or 100 times, 95 of the intervals that I gained from my samples would contain that true value. So we're pretty sure. No, don't panic. Don't panic. You're here now. You're doing some review ahead of time, so I'm sure you'll be fine. All right, so this was one of the questions in the questions before we got started. So the p-value, under the assumption that the null is true, this is the probability of obtaining the sample that we got. Okay, so if we assume that the true mean is 5, because that's in the null, the probability of getting the mean that we had in our sample is whatever our p-value is. That's why if that's low, we have reason to doubt something. Okay, but you have to include, if you're interpreting a p-value, you have to include that you're assuming that the null is true. Okay, basically the null gives you a normal curve. You place your sample on that normal curve and then find the probability of that or less or that or more. Okay, that is how you do the that's how you interpret the p-value. And then so be sure to include that you're assuming the null is true. Now a lot of times they'll give you D and E. Like part D is to interpret the p-value, and then part E is to conclude based off of that p-value. Those are different things. So make sure you read the question carefully to know what it's actually asking you to do. All right. So your conclusion is the P is low, you drop the hoe. That's what most people kind of follow. Okay. So if my P is less than alpha, I reject my hoe. That means that you would have significant evidence that the true mean is whatever the alternative hypothesis is, okay? If the P is not less than the alpha, that means that we would fail to reject the hoe, okay? So that is basically your first sentence here. P is low, you drop the hoe. P is not low, you don't drop the hoe, okay? You never accept anything. Your first sentence is what decision are you making about the null? Are you rejecting the null, or are you fail to reject the null? Your second sentence is what are you doing about the alternate hypothesis, okay? If I'm rejecting the null, that means that I have evidence of the alternate. If I'm failing to reject the null, that means that I do not have evidence of the alternate because I'm not rejecting it, not rejecting the null. Okay. He probably is. You're right. So that's a really good template to follow. Make sure you have context. Again, there's that word context again, over and over and over. Okay. The first sentence is your judgment on the null. Your second sentence is your judgment on the alternate based on what you said in the first sentence. Okay. All right. So this is a COVID style FRQ from 2011, number 5. Back to that regression question that we had. We are going to go through this pretty quickly because we're getting low on time, and I want to look at the questions y'all have in the Ask a Question section. Okay. All right. So basically, it says windmills generate electricity by transferring energy from wind to a turbine. A study was conducted to examine the relationship between wind velocity and electricity production. So the wind velocity is our X. It's our explanatory variable. And our electricity production is our Y, which is our response variable. So we have 25 randomly selected days, and this is our computer output, which we already are familiar with. Okay, so first thing that you could be asked maybe to do is identify the explanatory and response variable, which is kind of what I did in reading the question there. Okay, so explanatory is the wind velocity in miles per hour. The response is the electricity produced. I would not assume the first variable that's stated to be the X. The one that's in your computer output is your X, but not in the problem. It could be worded differently. Okay. Same thing. Part B, identify and interpret the slope. So remember, constant is always your Y-intercept. So slope is going to be 0.24. And that means that the predicted increase in electricity production is 0.24 amperes for every 1 mile per hour increase in wind velocity. So some key things here. The predicted increase in Y, electricity production, okay, for, go away. That's one thing I hate about Google Slides is I can't make that thing go away. Try to stretch it to make it change, but it's not really working. All right. So think about it, rise over run. So your rise is 0.24. That's your predicted change in Y. Key point there, predicted. And the X is going to be 1, okay, for every 1 increase in wind velocity, which is your X. Okay, it's just rise over run. It's the predicted rise over the run of 1. All right. What proportion in variation in electricity production is explained by its relationship with wind velocity? That sounds a lot like the R-squared definition, okay, which is what it is. This question had that exact format, okay. They stated the definition for R-squared, and you just had to know that. It was kind of like a multiple choice question. So 87.3% of the proportion in a variation in electricity production is explained by its linear relationship with wind velocity. Since the R value, so that would find that by taking the square root of 0.873. Since the R value is 0.934, we have a strong, it's positive because the slope is positive from the last question, and it's linear correlation between my X and my Y, wind velocity and electricity production. I have the 4 components for interpreting are strong, positive, linear correlation, and then the context of X and Y. I would say yes, because it does say, is this a good correlation? Okay. You probably could kind of make that judgment by saying that R squared is also pretty high. You do not need to know sampling distributions for linear regression. That is Unit 9, not on this year's test. Okay. So I'm just trying to think of things that we could do for that. Oh, didn't mean to go that far. So it says, to better judge whether windmills were producing enough electricity, researchers took 2 different windmill fields in Texas and Oregon to see which state seems to produce a higher proportion of windmills that are producing at least 100 amperes daily. Researchers measured 250 windmills from each field to see if both locations produce electricity that is not equal to one another. State the test to be used here and the appropriate hypotheses. Okay, so I have 2 samples, and this is a proportion because I'm looking at what proportion produces at least 100 amperes. Okay, and we're looking at the difference in those, the difference in the proportion of windmills in Texas and windmills in Oregon. And since it is proportions, we're going to do a 2-prop Z test. So that's my test. And then my first hypothesis, your HO is always equal. Either P whatever equals something, or equals 0, or equals 5, or, well, if it's P, it would be 0.5. Okay, you know, some sort of proportion. In this case, it's 2 populations. So it's P sub T equals P sub 0 or sub O for Oregon and Texas. My HA is that they're not equal. And that was pretty clear right here. I think, yes, you would get points counted off. Your hypotheses are always P or mu. Okay, because your hypotheses are dealing with the population, not just your sample. Okay, so yeah. Hypotheses, always parameters, not statistics. Population parameters there. All right, and then I should have clarified. I didn't. Whoops. I should clarify that P sub T is the true proportion of windmills in Texas that produce at least 100 amperes. And then after running a test, they get a p-value of 0.003, assuming that the proportion of windmills producing at least 100. Yes, you could do P1 and P2. That's perfectly fine too. So yeah, this is that p-value definition. So we're assuming that the 2 proportions are equal between Texas and Oregon. The probability of getting the sample proportions that we had would be 0.003. So really, really low. But yeah, so it has that part that we are assuming the null. Okay, I'm assuming the null is true. I'm assuming that that center of my normal curve is 0 because they're not different. And then what was the likelihood of getting the difference that I have between my 2 samples? Okay, and less than 1% chance, which is really low. All right, and then what should they conclude based on that p-value? The p is low, we drop the HO. So at the significance level of 0.05, we have significant evidence that the true proportion of windmills in Texas that produce at least 100 amperes is not equal to the true proportion of windmills that produce at least 100 amperes daily in Oregon. Yep, the HO always getting rejected. It could not be rejected. It could fail to be rejected, though. There may be hope for the HO. So anyways, yeah. So our P is low. We drop the HO. That means that we have significant evidence that the HA is true, which is that they're not equal. I really think the calculations will be done for you. Yes. Yes, I think the p-value will be given. They could ask you to conclude based off of a z-score or a t-score, though. And basically, if it's more than 2 or 3, then that would be, you would reject the HO. If it's less than 2, I would not reject the HO. Yes, I would say more interpreting and less mathing. Yeah, I guess they could ask you to read the p-value off of a sampling distribution. You know, if it's way to the right or left in one of the tails, then I would say it's probably a low p-value. Therefore, you would reject the HO. So you would not fail to reject. Okay. All right. So Q&A. Let me go to the question poll here, and I'm just going to start from the top. Difference between binomial and proportions. So remember we discussed a binomial is a form of a proportion. So a proportion is just the probability of something happening, and the binomial is a way that that could happen based off of those 4 conditions that we have. So we kind of talked about binomial distributions a little bit, and the complements, that's that P and Q, or P and then 1 minus P. If you do, I would do P and 1 minus P, but Q is not wrong. So today's bio exam was A through J. Josie, was that 2 questions or was that just 1? Did y'all have 1 question or 2? I don't know the AP bio. 1. So you had 1 question, parts A through J. Okay. I'm going with my thought is what Steph just said. I think that there's going to be 6 questions on question. This is just my speculation. I think there's going to be 6 questions on question 1 and 5 questions on question 2, 5 parts. That would be 11 parts total, and that would make the first question weighted 55%, which is what they stated, and the second question weighted 45% out of 11 parts. 6 out of 11, 5 out of 11. That's my thought. But that's pure speculation. It could be A through J, and I could be completely wrong. It may be A through J, but then B and C, like on the probability questions, those might work as 1 question. Sometimes in stats, they'll do B and then B sub I and B sub 2I. And really, those are 2 separate questions, but they work together. They may just do those instead of B sub I and B sub 2I, they may just be B and C, and then it might go to more parts. So I could see that happening. AP, Human Geography, 5 parts. So yeah, I really don't know. There's a lot of speculation. I think 6 and 5 is pretty common. I think I've seen a lot that lines up with a lot of things that College Board has been putting out on their practice tests. So that's my thought. You might have binomial or geometric. So yeah, 50% or higher, you should pass if you make 50%. Okay, no I and 2I. I would say that if it does go to J, that like B and C are working together towards 1 point of the 11 points. But I think it's going to be graded out of 11 points. It just matches everything really nicely. Binomial and geometric, I would say probably yes, maybe. I don't know. But if it is, it's not going to be calculating. It's going to be just how do you know it's binomial? How do you know it's geometric? That sort of thing. All right, those were my predictions that I just gave you. 6 and 5, 11 points total. If you get 5 out of 11, I think you're passing. I would shoot for 5 out of 11. I think you're safe. That's a good question about binomial more than geometric. I really don't know. So the difference in setting up 1 prop interval test or 2 prop interval test. If you're doing 1 prop, you only have to do the NP greater than or equal to 10, the large counts condition, 1 time. You have to do it twice if it's 2 proportions. A 1 prop intervaler test is if you're looking at 1 population and seeing if the claim given is true or false. If it's 2 prop, you're looking at 2 proportions or 2 populations and you're seeing if they're equal. And yep, you have check independence twice if it's 2 prop. Law of large numbers versus CLT. I always think of the law of large numbers as the more you do something, the closer you get to the true outcome. So if I have a sample size that's 4,000, I'm going to be really close to the population. Yes, that's a really good point. For independence, you do pooled, which is a really complicated check, and I don't think they're going to ask you to calculate that this year. The formula is pretty nasty because you have to come up with your piece PC and then use that. That's a good point. Difference between R and R squared. I think we discussed that earlier on. 10% condition when you're sampling without replacement. If it's a randomized experiment, you don't have to check that, which has been a lot of discussion on that the past few months with problems that have popped up. Yes, if your original sample is bimodal, then if your N is large enough, so if your original population, yeah, you're right. If your population is bimodal, and then you take a sampling distribution of something more than 30, then it would be approximately normal. Yes, that is true. We did the p-values in context, assuming the null is true. That's the big one there. Yes, that's given by a central limit theorem. Law of large numbers doesn't really apply in AP stats that much, although it is a really interesting concept. I mean, it does, but you don't like prove something with it. Oh, percentiles. All right, so P is when you're dealing with a proportion. P hat is when you're dealing with a sample. So your hypotheses will always have P. Your samples will always have P hat. And then Y and Y hat is actually something different. Y hat is when you're doing regression. You have to use Y hat because it's a prediction. The hat means that it's a predicted value of Y. We don't know what the actual response variable is. We can just predict that. Assumptions versus conditions, not really sure. I think those really are the same thing if I'm reading that correctly. Y standard deviation divided by n minus 1 and not n. That is beyond the scope of this course. That's probably some fancy calculus that gets you it there, and that's we could be here all night debating that. Changing units doesn't change R, flipping X and Y. So what changes are if you completely, outliers, if you completely throw the data points in somewhere random. But X and Y is still going to follow that, that random thing. So the Cram chart, I think they're still working on that. For each unit, the Cram chart, I think that should be out before Thursday, hopefully. So it should be coming up. Conditions, we went over that. Stratified and cluster. So again, I think the M&M stratified, I split them up by color and take one from each color. Cluster, I pour a little bit into 5 different cups and take 1 cup. Stratified is a form of blocking. I'm blocking the bias of color by using that. Okay. All right. I think, is that it? Percentile and the calculator. I was going to come back to that, Steph. So the percentile is, yes, if you were calculating a percentile, it would be inverse norm. Okay. So inverse norm, you would do your mean, your standard deviation, and your area to the left. So percentile is the area to the equal to and to the left of that particular value. Okay. So if you're in the 95th percentile of height, that means that you are taller than or equal to 95% of people in the world. Okay. But in your calculator, it would be inverse norm if you were calculating the percentile. Yes. Okay. It's equal to and below a value this year. They changed that this year. I don't really know why they changed that, but that was one of the changes in the CED for this year. I highly doubt percentile is going to be on there. That generally was like a multiple choice question or two. I think we're looking at more of like the big picture this year with such a shortened test. But yeah, percentile, I always thought of it as below a value. Yes, it was on there last year. But again, last year was a much bigger test. Last year, it was below a value. And between last year and this year, they changed it to equal to and below a value. So if you're the 95th percentile, you are, for height, you're taller than or equal to 95% of all people or whatever. Okay. Any other questions? Any other questions? Thank you guys who are so active in the chat tonight. Hope I didn't get too distracted trying to answer questions and go over the stuff I had set out, but I'll hang out for a minute or so. If you have a question or something, I'll be glad to help you out. How do you know if a game is fair? If the person is really enticing you to play the game, against them, it's probably not fair. That's game theory. That's also beyond the scope of this course. Go watch A Beautiful Mind. If it's free, then it's fair. Maybe. So yeah. So with a probability distribution, if it's fair, then you would have an equal chance of winning as you would losing. There's no bias for one player or the other player. Again, beyond the scope of this course. Go watch A Beautiful Mind. All right. Anything else? Any other questions? Good luck to everybody. I have enjoyed being here for the past 8 or 9 weeks with you guys. I'm sure that you all are going to do fantastic. Join us Thursday on the Cram Pass finale. I'm not sure what time it's at, but it will be the best $5 and the best 5 hours you've ever spent in preparing for AP Stats. And you guys go and stat it up on Friday, not Saturday. So I can't say Saturday. I can just say Friday. Go and stat it up and knock it out of the park. Thanks, you guys. Y'all have a fantastic evening and week.